Kumar, and today in this video we are going to discuss the class 10th CBSE mathematics, and in mathematics we are going to discuss a very important chapter of algebra, that is quadratic equation. So if we start the introduction of quadratic polynomial, in our junior class, in 9th class, we have studied about the polynomial. Quadratic equation is also a special type of polynomial. So a polynomial which has highest power of degree equal to 2 is called quadratic polynomial. Here the term degree has also its own importance. In any polynomial, the highest power of variable is known as degree, and for a polynomial to be a quadratic equation or to be a quadratic polynomial, the degree of that polynomial must be equal to 2. Means the highest power of variable should be 2. General form of quadratic polynomial. A polynomial of the form ax square plus bx plus c, where a is not equal to 0, is a general form of quadratic polynomial. Quadratic polynomial. Here, the general format ax square plus bx plus c, where a is not equal to 0. So, a polynomial should be a quadratic polynomial. So, this condition must be satisfied. Why? Because if a becomes 0, the first term of this quadratic polynomial becomes 0, and the remaining polynomial remains no more a quadratic polynomial, because in the remaining polynomial the degree or highest power of variable is 1, which is not true for a quadratic equation. So this term must be present in the quadratic equation. Here the symbols a, b and c are just the constant, and they are real number, where a, b and c belongs to real number. A is called coefficient of x square, b is called coefficient of x, and c is the constant term. So here this is the description of a quadratic polynomial. A polynomial becomes equation if the entire expression equates to 0. So this quadratic polynomial can become a quadratic equation if the expression is equal to 0. So let's discuss the quadratic equation. Quadratic equation. Ax square plus bx plus c equals to 0, where a is not equal to 0 is the standard form of a quadratic equation. And if we talk about the concepts of polynomial from the previous class, we know that a polynomial has that is the degree that has inner number of solution. Means if a quadratic polynomial has degree 2 or the variable has highest power 2, then this shows that this equation must have two solutions. What is the meaning of solution of a equation or solution of a polynomial? So, solution of x is defined as those values of x for which the entire equation is equal to the 0. Those values of x are called the solution of any polynomial. So, here in the quadratic equation, the variable has highest power which is equal to 2. That's why a quadratic equation has two solutions. Solution or zeros or roots of a quadratic equation. Quadratic equation. We use all these three terms, solution, zeros and or roots of a quadratic equation. All these three terms have the same meaning, and we have already defined that solution of any polynomial is that value of the variable for which the expression becomes 0. So let us take an example. X square minus 5x plus 6 equals to 0. So this is a standard form of a quadratic equation. If we try to find out the solution of x by a factorization method, let us split the middle term like this: x square minus 3x minus 2x plus 6 equals to 0. Let us take x as common, x minus 3, here minus 2 is common, x minus 3 which is equal to 0. X minus 2 into x minus 3 is equal to 0. So, if we look at here, we have two terms which are in product which is equal to 0. So, how we can find out or how we can get the solution of x for this equation? So, if two terms whose product is equal to 0, then from here we can draw two concepts. We can draw two important points. What are those? Maybe it can be possible that the first term is equal to 0 and second term is equal to non-zero, then also the product is equal to 0. So, if we assume that its first term is 0, let us write here, if x minus 2 is equal to 0, then x is equal to 2. Here we have got our one solution of x. It can be also possible that the second term may be 0 and the first term is non-zero, then also the product is equal to 0. If x minus 3 is equal to 0, then x is equal to 3. This is the other solution. If we look at the degree of a quadratic equation, it has a degree or highest power equal to 2. So from it, we can clearly say that this equation, this quadratic equation has two roots, has two solutions, or having two zeros. The value of first solution is x is equal to 2 and the value of second solution is x is equal to 3. We can verify whether x is equal to 2 or x is equal to 3 is the solution of this quadratic polynomial or not, or this quadratic equation or not. This can be verified. So from the definition, if x is equal to 2 is the solution of this quadratic equation, then this equation must satisfy the value of x equal to 2. Means if we put x is equal to 2 in this quadratic equation, then the entire term or entire quadratic equation becomes 0. Let us check that. Putting x equal to 2 in the LHS of the quadratic equation. LHS is equal to x square minus 5x plus 6. So let us put x is equal to 2 here. So 2 square minus 5 into 2 plus 6. So 4 minus 10 plus 6. 10 minus 10, which is equal to 0. So clearly we can see here, if we are putting x is equal to 2 into our quadratic equation, the equation becomes 0. So this shows that x is equal to 2 definitely is a solution or root or 0 of the quadratic polynomial. Let's check for the other root also. Let us check whether x is equal to 3 is the solution of this quadratic equation or not. Let us put x is equal to 3. X is equal to 3 in the LHS of the quadratic equation. So LHS is equal to 3 square minus 5 into 3 plus 6. So 3 3 is 9 minus 15 plus 6, which is equal to 15 minus 15, 0. So x is equal to also 3 is satisfying our quadratic equation. So x is equal to 3 is the other root or other solution for the same quadratic equation. So here we have found out that this quadratic equation has two roots, x is equal to 2 and x is equal to 3. Every time when we solve a quadratic equation, we will get two roots. Whatever the possible cases about those two roots, we will discuss it later. So, there are various methods by which we can find out the roots of a quadratic equation. This is also very important. If we have given a quadratic equation, then how we are going to two roots of that quadratic equation? There are special techniques, there are special methods. The first and very simple method is solution of a quadratic equation by factorization method. Already, whenever you learn about the factorization in algebra, you have used this technique. So, we will use the same technique of the factorization to find out the roots of the quadratic equation. Let us find out how the roots of a quadratic equation can be determined. Determination of roots of a quadratic equation. The example that we have discussed just few minutes before, the solution of that quadratic equation x is equal to 2 and x is equal to 3 is determined by the same method. So we will discuss by first method, by factorization method. Let us take how this method can be applied in order to find out the roots of a quadratic equation. Let us take example x square minus 3x minus 7x plus 21. Sorry, x square minus 10x plus 21 minus 10x plus 21 is equal to 0. So before we directly start our process to find out the root of the quadratic equation, first we should think for 1 second whether the given expression is a quadratic equation or not. So by looking at the polynomial, we can say that this equation must be a quadratic equation, because here we have a variable which has highest power of degree which is equal to 2, and the term is exists here. That's why it is a quadratic equation. Let's find out. So how we are going to find out the roots of this quadratic equation? By factorization method. There is a very important key rule here. The middle term 10x can be split in such a way that the sum or difference of those two digits is equal to -10, and the product of those two digits is equal to 21. Let me repeat it once again. The technique of factorization method works with the second term. Just look at the second term, or the term which has a coefficient 10, and we have to split the coefficient of this term in such a way that sum or difference must be equal to -10, and its product must be equal to the last term 21. So what are the two numbers whose sum or difference is -10 and whose product is 21? I think 7 and 3 are the two terms. Actually it is -7 and -3, because we have to get the sum or difference equal to -10. So we will take x minus 7x minus 3x plus 21. Why it can be taken like this? Why it cannot be split into any other coefficients? Because if we look at the -7 and -3, the sum of -7 and -3 is equal to -10, and the product of -7 and -3 is equal to 21. Now it is going to be very easy. Let us take the common x from the first two terms, x minus 7, and in the next two terms let us take a common -3, x minus 7. So x minus 7 is common in both the terms. Let us take common as x minus 3. Again, this quadratic equation is factorized like this. This quadratic equation comes as a product of two terms, and the product of these two terms is equal to 0. What should be the possibilities here? The first possibility here is the first term can be 0 or second term can be non-zero. So, what are the results if we assume the first term is 0? All the possibilities should be involved here. All the possibilities should be taken care of here. The first possibility we are going to take is x minus 7 is equal to 0. So x is equal to 7. This is our first rule. Let us find out. The second possibility here is that we don't know whether the first term or second term is equal to 0. So it can also be possible that the second term is equal to 0 and the first term is equal to non-zero. In that case also, the product of these two terms is equal to 0. So let's take that. If x minus 3 is equal to 0, then x is equal to 3. This is the second solution of quadratic equation. Still, whether these two solutions are correct or not, this can be checked. This can be cross-checked or this can be verified. How it can be done? So put x is equal to 7 into this quadratic equation. If the left hand side of quadratic equation evaluates 0, means x is equal to 7 is a quadratic equation. If we put x is equal to 3 in the same quadratic equation, the LHS of the quadratic equation evaluates 0, which shows that x is equal to 3 is also the solution of the same quadratic equation. So at the conclusion, what we can say here is that every quadratic polynomial has two roots. It cannot be possible that quadratic equation has 3 roots. Why? Because the number of solutions given by any polynomial is equal to its degree or is equal to its highest power of the variable. And in a quadratic equation, the highest power of variable is 2. So only there are 2 roots can be possible, not more than 2. So this is one of the method. This method you have already known in the previous classes, but still you have to use it, you have to apply it, and you have to do a lot of question on this basis. But this method has certain limitation. Every time you are not able to factorize the quadratic polynomial. It can be very difficult because by thinking we have to split the middle term. If we cannot think in which 2 terms we should split the middle term, we are not able to use this factorization technique. The other and very short method is by using quadratic formula. First we will derive the quadratic formula, and then we will use how this quadratic formula can be utilized or can be used to find out the roots of a quadratic equation. Quadratic formula, and this formula is derived by Indian mathematician. That's why this formula is also called Sri Dharachan Sutra. Quadratic formula. This is a method by which each and every quadratic polynomial can be solved. So let us derive this formula. So to derive this formula, let us assume a standard quadratic formula. Quadratic equation ax square plus bx plus c is equal to 0. Let us mention once again here a is not equal to 0. If we divide the entire quadratic equation by a, what? Dividing throughout by a. So let us divide each and every term by a. Ax square by a, x square, bx by a plus c by a